All right, so you had to say, I guess just what these were. So if X represents the books in the library, if your books are countable, you don't have a partial book, so that's discrete. The length of time, if you can say, can I go an hour and a half? If you could use a half, then it's continuous. The volume of blood, can I draw half of a unit, whatever? Yes, it's continuous. The number of tornadoes, they're countable, discrete. The number of messages posted, you don't post a partial message unless you hit send by accident, so discrete. The amount of snow in inches, can you have a half an inch of snow? Yeah, continuous. Okay? Questions at all? All right. Your probability distribution. A lot of you were asking what to do with this. We kind of did this. A lot of the times the book does a horizontal one. They do it horizontally, it takes less space. So like a horizontal line here would take half the, like less in the page. So when they're looking to save space, a lot of their graphs are horizontal. Can you do a vertical? Absolutely. What was the total of this? 2006? 2,600. I know it was a pretty big number. So all you're doing is this. Part over whole. 26 over this. 442 over this. This is the same as your relative frequency. Part over whole. 728 over 2,600. And give me 3 decimal places. When you do your mean, that's when you multiply these guys. So can somebody just whip down these decimals if you don't mind?
0.01, 0.17, 0.28, 2.5.
And what should these all equal? 1. Now, when you're looking for your mean, that's when you do this guy. That's when you multiply this times this and put it over there, and then you take the sum of it, and that's what's going to give you your mean. Or your calculator L1, L2, or L1, L2 using your decimal. If you use your decimal, you get no sample standard deviation. That's the only difference. Okay? So are we okay with finding probabilities? Probability is just basic part over whole. We're just looking at it in a little bit differently. This just was another way to ask you these things. So using these probabilities, take it right off your table. What's the probability that it had 1 or 2? These are mutually exclusive, so add the 1 and the 2. I don't know why these answers didn't show. I must have not saved them. 2 or more. What am I going to add for 2 or more?
2 or 3.
2 or 3. So 2 or 3. Okay. Between 1 and 3, if this said inclusive underneath it, right?
No.
Between 1 and 3 inclusive means include those numbers. Between 1 and 3 just means 2. So you're adding these 3 together. So all you have to do is take this one and just add a 0.17 to it. Okay, and that makes sense. The only one left is 0.01. So if you wanted to use your complement case, you can use your complement case here as well. But the only one you didn't use was the 0 one. Remember this chart too. The one thing that you have to get used to is 0 is a possibility, that none respond. A lot of times kids forget the zeros. All right, we check to see, are your probabilities between 0 and 1? Yeah? They want to know what the sum is because we're missing one. The sum has to be 1. So add them all up and subtract. This guy I had to change yesterday because this was the one they made a mistake on. Otherwise you were already over 1, which some of you noticed.
346.
They're supposed to come in here. I got you carols all day long here.
Oh.
They didn't come in my first period.
They didn't?
No.
You gotta call the music teacher.
Well, I kind of forgot about it too until the end of the period. I saw them walking by.
Yeah, I think didn't you pay good money for that?
Yeah.
They have a lot of people who know,
They actually had a lot more than they thought they were going to have too. So, okay, are these probabilities? They have to be between 0 and 1, and they have to add up to 1. This guy, yes. This guy, no.
I agree.
You agree? Concur? Good. See, a lot of these weren't so bad. Again, here is where you wanted to find your probability first, and then do your mean. So, part over whole, again, to find your probabilities. Then if you did the x times your p of x, and you took the sum of that, that would give you your mean. Your mean you can also get from your L1, L2. I have no problem with you doing that. You had to put it in your L1, L2 to do your standard deviation. So, you know, if you didn't want to do this category, I think they asked you to do it, but it comes out the exact same. So this tells you, on the average, every household has 0.5 dogs. So we know you can't have 0.5 dogs, but on the average, they have 0.5 dogs. Between 0 and 1 dogs they have. Either they have no dogs or they have 1 dog. The mean is, I added them all up, 0.5. If you put it in your L1, it's the X bar. The X bar on your calculator. Otherwise, the mean is just your average. But because this has a frequency, you have to multiply these to get that guy. Multiply this times this, and it gives you this one. You have to multiply your x times your p of x, and then you can take the sum. Or you can just put it in your L1, L2. So if I do L1, L2, or I can do L1, L2. Either way. And that you got to do it anyway to get your standard deviations. So the x bar, the first thing when you do is stat calc. When you get your x bar, that's your mean.
I think I did it wrong because I added up all of my x's and I got 0.8.
But you added up all your px's?
Yeah, I added the x, I multiplied the x
Times that?
and then I added them all up and I got 0.8.
Yeah, maybe something happened there. Check them again. We good with this? Everybody can find your variance. Remember, we find your standard deviation first. Go to the VARs, do statistics, pull out your standard deviation, and square it. What's that, John?
Huh?
What was that?
Oh, no, I just had a question on number
30?
30.
Wait, I passed it. What was your question?
No, 33.
33?
Yeah.
Okay.
I don't know how many answers yet, though. I thought I might have done it wrong.
You found you did wrong? Do I have
I still think I might have.
There's no actual questions or You already did the same thing.
Oh yeah, you just have to pull it out and make a table. So I just pulled it off your graph. You know how they always give you like a circle graph? They give you a bar graph. They want you to interpret your graphs as well. But they put the probability on the top of every bar. If they didn't put that probability there, you'd never be able to get the exact probability. So they put the probabilities on the top of their bar, and then they just ask you to find, if I can move this down, and I did find it, the mean. If they asked you to find your mean and everything else, is that it? I don't know why half of my answers are not coming out here. So your mean. Hi guys. Looks like I can't write either for some reason. I don't know, this always happens to me. Your mean for this guy is 2.0. Put it in your L1, L2. This is your variance. About, they have 1.0, and their standard deviation is 1. Square root of that is 1.0. So on the average, you can expect a Category 2 hurricane. Okay, that's all it's saying. You just have to pull it off your chart, put it in your L1, L2. Everybody good with this? What was that?
Oh no, they put like.
I think it's this guy that gives me grief. Okay, expected value. If your expected value between your profit and loss analysis is zero, that's your break-even point. And you guys are probably learning that in economics, right? When your costs and your things work out the same, they kind of wash out. That means the money that you lost was equal to the money that you spent to get that money that you lost. The money that you spent is equal to the money that you gained. So it washes out. You bet $5, you win $5. It's a wash. It's zero. That's your break-even point. So you probably do this in economics, right? Break-even.
Yeah.
Everybody's saying, no, please don't talk economics. But economics, when you do the economics part, it will be so much better. You get such a better understanding of everything. I think when you see that, where everything bounces, when you do the graph, and you see what's above, what's below, it does start to make sense.
You just got to this.
Don't you do graphs like that?
There's like a dotted line.
Yeah.
I don't think it's
But when you do that, I think it really gives you a better feel for it. You know, like what's the operating cost of the profit is absolutely. Okay, this was a little bit confusing. Your wheel has 38 numbers on it. How many numbers win when they do this? When you spin the wheel, how many numbers come out a winner? One. So that means you have 37 losers. You have one winner. So they wanted you to do, and if you make a chart, they just wanted you to say, so you have 37 out of 38 wins, loses. Here's your loser guy, and you're gonna lose how much money? A dollar, right? You're gonna lose $1, and here you're gonna win $35 one time. So they want you to multiply these and then add them together. This would give you your expected value. So if you do this, this multiplies to -1, -37 over 38, and this multiplies to 35 over 38. So you're expected to lose money. So you're expected to lose, and you could probably reduce this down to a decimal. Makes it make more sense for money. What does this reduce down to? It's almost like a nickel, right? 1 out of 19, so like 1 out of 20. It's for about 0.05. You lose about a nickel. Okay, because when you win, this one was a little bit different. When you win, you got your dollar back. So you didn't have to say, I won $34. You got your dollar back, and you received an additional $35. So it didn't cost you anything to play when you won. In the other game, it cost us $1 to play, but not this game. And then this one was like and then this last one was like the other one that we did. We had to have to do this now. And this one was like the other one. How many raffle tickets? You spend $5 on your raffle tickets. Your first prize to Mexico is valued at $34.50. Your second prize, $7.50. The remaining 20 prizes are $25 gas cards, and the number of tickets sold is 6,000. So if I sell 6,000 tickets, 25 winners here, 1 winner here, and 1 winner here, how many tickets are winners? 2 plus 20, right? Because you still win. You win, so you have 22 tickets that are winners. Therefore, you have 5,978 losers. So you're going to lose $5. 5,978. You're not geared to win this. And you're going to spend $5 and win a trip valued at $34.50. Subtract your $5. 34, 45, 1 out of this guy. and then $7.50, subtract your $5. So you're going to multiply these guys, and then you're going to add them up for your expected value. Did anybody get a number? I don't know why half of my stuff didn't print out. Did anybody do this? Okay, so you're expected to lose about $4.26 every time you buy a raffle. For every raffle ticket. Okay, again, if you bought every raffle ticket, $5 times 6,000, you're spending $30,000. Okay, and you're not winning enough to cover what you put into this if you were the one to buy every single raffle ticket. And remember, raffles are not designed to break even. Raffles are designed to make money. Okay, so that's why you're never going to make out on that. Yes.
Do we add in 25?
Oh, I forgot to add in the 20 prizes. Thank you. So 20, and you said you forgot. Now I forgot this one. So if you spend $5 times 20 of these,
So it's that number plus 25 times 20 over 6.
so you're making 20.
20 and 29.
No, you're making 25, and that's 20 over.
But you paid $5. To win your $25 gas card, you paid $5. So that's 20 over this amount.
Yeah, but the number above it implies the price of the prize.
This is the price of your prize, $25 gas card. But you paid $5 on your raffle ticket. So you give me $5 for your raffle ticket. I say, oh, here you won. Here's a gift card for $25. How much did you essentially gain on that? 20. You had to pay me $5. That's why we took the $5 off of this one. We took the $5 off of this one. So that'll make this a little bit better. So what did we say? So you still almost lost the same thing. You still almost lost the same thing because it wasn't enough. It's over 6,000, so it's really not enough to make a difference. So approximately you lost $4.26 per ticket. Expected gains, when you do something like that, really doesn't net you anything because